going to identify and describe the transformation. We're going to put this into words. We're not going to write it on a graph. We're just going to put it into words. And we'll just move left to right as we're doing this so that we can make sure that we understand and pick up each piece that we need to describe. We're looking for reflection. We're looking for dilation. We're looking for transformation up, down. We're looking for transformation left, right. Okay, 4 things we're looking for. It doesn't have to do all 4, but those are the 4 things we need to check for. Does everybody agree? Okay. So as I read this graph left to right, the first thing I see is this negative. What does it tell me? It tells me it's a reflection. Specifically a reflection across the x-axis. Right? Flipped it upside down. Does everybody agree? Reflection.
Oh, that's symmetric?
Yes. Yes. Okay. Okay. Moving on across, I get to the 4. What is that 4 representing? What variable that we've talked about?
The H.
It's representing the H. What do you know about it? It really means what right here? X minus what? Negative 4. All right, so I have x minus negative 4. So what do you know about your shift there? Shifts left 4 units. Still with us? All right, and lastly, I make it to the what? Which represents what variable? K. And that tells me I'm going down 1 unit. Okay? Describe this one. All right, we're ready to check it? Does it reflect?
No.
Does it dilate? No. Does it move right or left? Which one?
Right.
Shifts right. How many units?
1 unit.
1 unit. And then lastly, it does what? Goes up 3 units. Is everybody good there? All right, looking at this last little piece, we want to look and see, can we write the equation based off the graph? Okay? Can we identify the things we need to identify based off the graph? Is everybody with me? So I'm kind of asking myself some questions. Does it reflect? Does it dilate? What's its H? And what's its K? And I'll talk about why I put the H and K that way in just a second. So first question, does it reflect? No. Does it dilate? No.
How do you know if it dilates?
Okay, so the parent function was 1 up 1 over 1 on both sides. This one does the same. So that means it didn't get skinny, like more,
Like in both of the voices.
it didn't stretch up. It didn't get skinnier as a V. It didn't get wider as a V. Okay. Okay. I was trying to get this view. Sorry. All right. So the next thing I want you to note, and I just will go ahead and apologize to those of you that had me for Algebra 1 because I may have stumped this up. But those of you that didn't, if you had Algebra 1 in middle school, you've seen this form right here. This is what they call Vertex Form. And so if you learn this, then you know that the H and the K actually represent your vertex, or in other ones, it's your starting point or your turning point. We're going to talk about those as we get into other functions, so I want to say that. But in absolute value and in quadratic, it's representing that vertex. The H representing the X value, and the K representing the Y value, right? The left, right, that's the X's. Up, down, that's the Y's. Makes sense, right? So my H here would be, I shifted from 0 over to -3. Still with me? And my K, I shifted from 0 up to 4. So now I want to write a function. You can name it whatever you want to. I'm going to name mine J of X. I like J. It's a good initial. You can name it whatever you want to. So I've got J of X, and you said I don't reflect and I don't dilate, so I don't have an A. I have an absolute value function, so I'm going to put my absolute value bar. And I know that this is going to be minus a -3, right? So what does that mean for me? It's going to be X plus 3. So the H always appears opposite of what it actually is. You with me? And then on the outside, I'm going to add 4 for my K. So all I did was take my H and K and plug them in. And if I'd have had a reflection or a dilation, I would have plugged that in also. Any questions there?
Can you revise the K 4, please?
Because we went left 3 and up 4 to get to the new point. Right, my parent function would have been right here, right? So I went from this point right here, I went to the left 3, and I went up 4, and there's my new point. Okay? You try this one. ask yourself those questions. Does it reflect? Does it dilate? Does it, what's its H movement? What's its K movement? What type of function is it? Is it absolute value? Is it linear? Is it quadratic? Sorry. Watch out, I'm going to write it there. Because remember the formula, double negative made it look like it was positive.
So here, I should have put it minus two.
Yes. Yes.
So you just like put the opposite.
Yep, except for this was a parabola, not a V. So this should have been the quadratic function.
Oh, yeah.
Yeah. All right, so let's look at it. Did it reflect?
Yes.
Yes. Did it dilate?
No.
Nope. Did it shift left or right?
Yes.
Which way?
Right.
Right, 2. Did it shift up or down?
Yes.
How much?
1.
1, which way?
Up.
Up. Now, with that being said, what are we basing the up-down movement off of?
The center.
The what?
0, 0.
Origin.
The parent function.
The parent function. Everything is always based off the parent function. You shifted right, you went up, and you flipped over. Does everybody agree? Okay, so it should have looked something like, we'll go back to boring old f of x. Should have been negative, and then we had an h of x minus 2 squared. We're using a parabola. If you did absolute value, right? We went to a parabola, and then we added 1 at the end. Any questions? All right, you have the rest of the class period to work on your homework.